Now let us discuss what are these techniques. Now first of all, consider this room layout or this space layout where we want to find out the path. Now this is what overall our configuration space where we want to find out the path. Now in Meadow Maps, they are developing the areas or space, recognizable space in view, wherein priority will be given to the obstacles. Priority will be given to the obstacles. Now how it is done? There are transforms. There are transforms, which are 3D transforms. Now which will show the obstacles as big as a robot so that we can see that the walls, the obstacles are grown to the higher height. So view of robot now sees that grown obstacles, and now robot knows that where is obstacle and where is the space. Once obstacles are highlighted, now we have to decompose the space which is available for the path planning. So here on the view, what robot is finding, polygonal space or polygons are developed. They are acting as a line segments, or they are pairs of edges or corners. Using these convex polygons, this is just computer aided drawing where we will be projecting or making projections in free space so that robot's view will be seeing the empty space where path is to be planned is broken in different polygons. There will not be unique set of polygons. There can be different views, and every time what is angle of entry, that will depend, or where exactly current position of bot is there, that will be depending that what is selection or where is the selection of next node. Now the white space whatever shown here is said as freeway or free space where we are finding a path using Meadow Map. Once obstacles are grown, then free space is broken into convex polygons. Now it will be tasked to plan the path or convert the space into relational graph. For this purpose, we need to add different nodes, or here it is said as data points. We need to add data points. Here now what we are doing, we are entering path between the nodes. Again, all the data points which are available can be decomposed pixel by pixel and can be stored as a data points. This method seems to be good. It needs transformation. Meadow Maps transformation is used. But again, every time generation of the polygon depends on the whatever angles you are getting. So even though same free space is there, different solutions will be there because generation of polygons is non-unique. Second part is sensor data. For this particular technique, we need exact sensor data. There will be another problem, that is sensor noise. What if if original sensor signal is corrupted. This problem specially occurs whenever the corners are there, because you need some safety space while traveling through the corners. That's why whole technique depends on the sensor accuracy and correctness of the sensor data. Many times designers use path relaxation technique. Here now kinking is there, so whenever there is a corner, sometimes you can relax the path. So sometimes you escape from Cspace representation, you can enter in other polygon or other state, and you can just relax the path so that safety of robot will be ensured. Otherwise, as per correct calculations, the position may be coming towards the corner points. At that time, robot size and orientation can obstruct. As in these such cases, to avoid such kinking, paths are relaxed. This is called as path relaxation. Our next technique is generalized Voronoi graphs or Voronoi diagrams, GVD. Now this is classical technique. It is creating nodes. It is actually a result of relational graph. Now whole scene is decomposed in a line diagram. The obstacles are grown dark, and now in a free space, nodes are generated, and now path can join in a straight line or on ordinary lines. So it is exactly a line diagram. Now another technique is breaking Cspace into grid. Either you are having sensor data or camera view, you break up view into the grid. So here, if you are having fast hardware which reacts in real time, then for every view we can place a grid. Once again, remember, we need fast processors and fast cameras over here, because for every view, that is for every second, it is our position getting new views. So you place grid and then find out coordinates, but change in coordinates is a major problem. So you need higher hardware in this part, and it can track easily using rectangular grids. GVD is the projection of lines between the nodes. Identify nodes and obstacles and then connect the nodes. So it is like relational graph. So obstacle and node, this relation is there. In between this, now you are going for free space. Now these lines can act as path for robot. So this path can be followed. A tracking program can be done so that you can follow the same path. In rectangular grid, once you get coordinates, you can decide current position, previous position, and next position, and you can achieve your goal using coordinates. Now problems with GVG, that is sensor data, very important, sensitive to the noise, nodes should be very accurate, boundaries should be defined very accurately. In grids, There is always bias of previous scene. So you need to have real time response. Again, every time you have to align with a line or path on grid. So alignment problem is there. Now in metric path planning, we discuss all these techniques where representation, that is breaking up world space, is very important. Representation of that is another problem. Sometimes you need to ignore issues or relax, and sometimes you have to go to exact. So there is always uncertainty because of sensor noise. So you need special techniques to handle these problems. One more advanced technique is there, that is what called as wavefront planner. Now this uses sometimes like thermal camera, or sometimes it uses like camera techniques. So now whole configuration space is treated as a conductive material. So obstacles will have conductivity and other area will not have. So map will be looking like potential field, or it will be shown by arrows. So there will be region coloring, there will be graphics programming in your view. So your current view will be now modified. It scans pixel by pixel and later on it modify. Let us say this is what grid we have considered and this is what configuration space. Then in wavefront planner, this is one of the system I am showing, one of the known algorithm, where you can have sensing how the flow is happening. So as we say already, this is what conductive material. So we don't go over here like heat map. And now in remaining free space, you have got orientation. So these orientation markers are here in a workspace. And bot has to select markers and calculate the positions. Again, it needs special programming, graphics effects to find out the path. There are several systems, they are finding out path like this. So see, there is a start and then you have to select within this orientation a particular goal. This is what one system Trula, what we have got in the references that uses this technique.